What if everything you're experiencing right now, this moment, this video, the chair you're sitting in, the person you love, what if it's all just code running on some cosmic computer? What if our entire reality is a simulation? Now I know that sounds like science fiction, but here's the thing. Some of the smartest physicists, philosophers, and technologists on the planet are taking this idea seriously. And when you actually dig into the arguments, when you look at the mathematics and the physics that underpin our universe, you start to realize that the simulation hypothesis isn't just wild speculation. It's a legitimate framework for understanding existence itself. Today we're going to explore one of the most mind-bending questions humanity has ever asked. Are we living in a simulation? And more importantly, what does it mean if we are? This isn't about dismissing reality or retreating into fantasy. This is about pushing the boundaries of what we think we know about consciousness, physics, and the fundamental nature of existence. Because whether we're in a simulation or not, understanding the possibility changes how we think about everything. So stick with me as we break down the science, the philosophy, and the evidence that suggests our reality might be far stranger than we ever imagined. Let's start with the basics. What exactly is the simulation hypothesis? At its core, it's the idea that our universe isn't a fundamental reality, it's a constructed one. Think of it like this. We create video games, right? We build digital worlds with rules, physics engines, and characters that seem to exist independently within those worlds. But those worlds only exist because someone programmed them. The simulation hypothesis asks, what if a sufficiently advanced civilization did the same thing to us? What if they created our universe as a kind of cosmic experiment or entertainment? Now, this idea has been around in philosophy for centuries. Plato talked about shadows on a cave wall back in ancient Greece around 380 BCE. Descartes worried about an evil demon deceiving him in the 1600s. But what makes the modern simulation hypothesis different is that we now have actual scientific arguments supporting it. And that's what makes this fascinating. We're not just philosophizing anymore, we're looking at real physics. One of the most compelling arguments comes from what we call the simulation argument, formulated by philosopher Nick Bostrom in 2003. His logic goes like this: if civilizations can advance far enough, they'll eventually have the computational power to create simulations of conscious beings. If they can create one simulation, they could create millions or billions of them. If that's true, then statistically speaking, one doesn't need millions or billions. We're far more likely to be living in one of those simulations than in the original base reality. Think about the math. One base reality versus potentially billions of simulated ones. The odds are stacked. Bostrom himself doesn't claim the simulation hypothesis is true. He just shows that at least one of three things must be the case. Either advanced civilizations never reach the point where they can run these simulations, or they choose not to run them, or we're almost certainly living in one right now. And here's where it gets interesting. We can't easily rule out the first two options, so we're left with a genuine possibility that demands our attention. The hypothesis isn't claiming certainty. It's claiming that given what we know about technology, consciousness, and the universe, simulation is a rational possibility worth exploring. And that changes everything about how we approach understanding reality. Consider this. In 2019, a survey of academic philosophers found that roughly 13% believe we're living in a simulation. That might not sound like a lot, but think about what that means. These are people who've spent decades studying the nature of reality, logic, and existence. And a significant minority of them think simulation is genuinely plausible. That's not fringe thinking. That's serious philosophical consideration. When you talk to physicists, the numbers are even more interesting. Many of them acknowledge that while they don't necessarily believe we're in a simulation, they can't rule it out based on current physics.
That's a profound shift from even 20 years ago, when the idea was almost universally dismissed as pseudoscience.
What's really changed is that major technology figures have started speaking openly about this. In 2016,
Elon Musk stated at a conference that the probability we're in base reality is very low, maybe 1 in billions.
He wasn't being flippant. He was making a serious point about the trajectory of technology. And when someone who's literally building the future says something like that, it shifts the conversation. It moves the simulation hypothesis from the realm of pure philosophy into something that serious technologists are grappling with as they design the systems that will shape civilization.
Now let's talk about the physics, and this is where it gets really compelling.
Our universe operates according to quantum mechanics. And quantum mechanics is genuinely weird. At the quantum level, particles don't have definite properties until they're observed. They exist in what's called a superposition, multiple states at once, until measurement collapses them into a single state. This is called wave function collapse, and it's one of the most mysterious aspects of physics. Here's the thing. This behavior is exactly what you'd expect from a simulation. Think about a video game. The game doesn't render every detail of the entire world at all times. That would be computationally impossible. Instead, it only renders what the player can see. Everything else exists in a kind of low-resolution state, until the player looks at it. When the player turns around, the game engine loads in the details. It's efficient, it's practical,
and it's exactly analogous to quantum mechanics. Particles behave like they're not fully rendered until they're observed. They exist in multiple states until measurement forces them to collapse into one.
This is called the observer effect, and it's a fundamental feature of our universe. Some physicists argue that this is evidence of simulation. If reality were truly fundamental and independent, why would observation matter? Why would the act of looking at something change its properties? But if reality is a simulation, this makes perfect sense. The simulation doesn't waste computational resources rendering unobserved details. Then there's the issue of the speed of light. Einstein showed us that nothing can travel faster than light, and light travels at about 299,792 kilometers per second. This speed limit seems arbitrary. Why this number? Why not faster? In a simulation, a speed limit makes perfect sense. It's a processing constraint. It's how the system prevents causality violations and keeps the simulation stable. If information could travel infinitely fast, the simulation would become unstable. The speed of light could be the simulation's maximum processing speed. There's also the cosmic microwave background, the radiation left over from the Big Bang. When we look at it, we see it's almost perfectly uniform across the entire sky. Almost. There are these tiny fluctuations, these slight variations in temperature. These fluctuations are so small and so precisely distributed that some physicists have wondered if they could be evidence of pixelation, like the universe has a resolution limit. If you zoom in far enough, does space itself break down into discrete units? Some theories suggest it does, and that would be consistent with a simulation running on a finite computer. The universe also seems to have a smallest possible unit of space and time, called the Planck length and Planck time. Below these scales, our physics breaks down. We don't know what happens. Could these be the pixels of reality? The fundamental units of the simulation's code? These aren't proofs. Science doesn't work that way, but they're observations that fit the simulation hypothesis in ways that are hard to explain otherwise. The universe has properties that look suspiciously like computational constraints. Now here's something that really crystallizes this. In 2012, physicists at Fermilab conducted an experiment to test whether space itself might be pixelated or quantized. They looked for evidence that space has a minimum unit size. What they found was surprising. The data suggested that if space is indeed quantized, the grid size would be incredibly small, on the order of the Planck length. But the fact that they could even design this experiment, that they could test for pixelation in reality itself, shows how seriously physicists are taking this question. We're not just talking about it in coffee shops anymore. We're designing experiments to look for evidence. Here's another fascinating detail. In 2019, James Webb Space Telescope observations revealed something unexpected about the early universe. Galaxies appeared far more mature and structured than our current models predicted they should be at that age. This contradicted existing theory. Now, this doesn't directly prove simulation, but it shows us something important. Reality keeps surprising us. It keeps violating our expectations about how it should work. That's consistent with what you find if you were exploring the boundaries of the system. You'd keep discovering places where the underlying rules don't quite match the surface appearance. You'd find inconsistencies that suggest deeper architecture beneath what we observe. I want to pause here and ask you something. How does this make you feel? Does it terrify you? Does it liberate you? Does it feel absurd? Because here's what I think is important. Whether we're in a simulation or not, this question matters. It forces us to think about consciousness, about meaning, about what's real. And that's the whole point. The simulation hypothesis isn't just an intellectual exercise. It's a tool for expanding your thinking about existence itself. If you're finding this fascinating, if you're the kind of person who loves exploring big ideas about the nature of reality and our place in the universe, then you're exactly the person who should be following Future Frontiers. We dive deep into these kinds of questions every single week. We explore the future, the possibilities, the science that's reshaping how we understand existence. So if you want more of this, subscribe now. Let's keep going. But here's the crucial question. If we are in a simulation, how would we ever know? This is where things get really interesting. Some physicists have proposed ways we might detect evidence of simulation. One approach is to look for glitches or anomalies in the universe, places where the rules seem to break down or behave unexpectedly. We've already found some. There are quantum entanglement phenomena that seem to violate our intuitions about locality and causality. There are dark matter and dark energy, which make up 95% of the universe, and we still don't fully understand what they are. Could these be signs of the simulation's underlying architecture? Could dark matter be the scaffolding holding the simulation together? Another approach is computational. If the universe is a simulation, it must have limits. It can't compute infinite precision forever.
At some point, if you measure something with enough precision, you should hit the resolution limit of the universe itself.
Some physicists have proposed experiments to test this. They've looked for evidence that space and time might be quantized, broken into discrete units, rather than being continuous. The results so far are inconclusive, but the fact that we can even test for this is remarkable. It means the simulation hypothesis isn't unfalsifiable. It's not pure philosophy. It's a framework that makes predictions we can actually investigate. Then there's the question of consciousness. If we're in a simulation, what are we? Are we simulated consciousnesses running on the cosmic computer? Are we copies of beings from the base reality? Are we something else entirely? This connects to one of philosophy's deepest puzzles, the hard problem of consciousness. Why do we have subjective experience? Why is there something it's like to be you? Why do you experience redness when you see red, rather than just processing the information about red? No one fully understands consciousness yet. But in a simulation, consciousness might be easier to explain. It could be an emergent property of sufficiently complex information processing. You could be a pattern of information that's sophisticated enough to become aware of itself. This doesn't make consciousness less profound. If anything, it makes it more profound. You'd be a conscious pattern in the fabric of reality itself. And that's beautiful. Let me give you a concrete example of how this thinking is changing neuroscience. In 2020, researchers at MIT and Harvard discovered that the brain processes information in a way that's remarkably similar to how digital systems process data. They found that neural networks encode information in a sparse, distributed manner, exactly the way you'd design a simulation to run efficiently. This doesn't prove we're in a simulation, but it shows that the mathematics of consciousness and digital processing are converging. The line between biological consciousness and digital consciousness is blurring, and that has profound implications. If consciousness is fundamentally about information processing, then it doesn't matter whether that processing happens in neurons or in silicon or in the code of a cosmic simulation. Consciousness is consciousness. There's a counterintuitive angle here that's worth exploring deeply. Like David Chalmers have argued that if we're in a simulation, we might actually have more grounds for meaning, not less. Here's the reasoning. If someone created this universe intentionally, if it was designed, then there's intention behind existence. There's purpose. Now you might think that would be limiting, like we're just characters in someone else's story. But consider the alternative. If we're in base reality with no creator, no designer, no intention, then meaning becomes something we have to create entirely from scratch. In a simulation, meaning might be built in. The universe itself might be structured to support consciousness and growth. That's not diminishing, that's liberating. It's also worth considering what this means for meaning and purpose. If we're in a simulation, does our life matter less? I'd argue the opposite. If anything, it matters more. Because consciousness and experience are still real, regardless of the substrate they run on. Your relationships are still real. Your achievements are still real. Your growth and learning are still real. The fact that reality might be constructed doesn't diminish any of that. In fact, it might enhance it. It might mean that we're part of something larger, something intentional. We might be conscious beings exploring the nature of existence from the inside. There's also a fascinating counterintuitive angle here. Some philosophers argue that if we're in a simulation, we might actually be more real than we think. Because consciousness itself might be the most fundamental thing in the universe. Our experience, our awareness, our capacity to understand and wonder, these might be the actual substrate of reality. The simulation wouldn't be a copy of something more real. It would be reality itself, just expressed in a different form. Consciousness might be the code. We might be the code. And that's not diminishing, that's elevating. Now let's zoom out across the broader implications of this hypothesis and think about what it means to how we live. Because here's the thing that really matters. Whether we're in a simulation or not, this question is transforming how we think about reality, technology, and consciousness. Look at the trajectory of human knowledge. We're at an inflection point. We're developing artificial intelligence. We're creating virtual worlds. We're learning to map the human brain. We're getting closer to understanding consciousness itself. And as we do, the simulation hypothesis stops being pure speculation. It becomes increasingly relevant. Think about where technology is heading. We're building more sophisticated simulations every year. Virtual reality is becoming indistinguishable from physical reality. Artificial intelligence is becoming more capable. Neural interfaces are connecting brains to computers. If we continue on this trajectory, eventually we might reach a point where we can create fully realized digital universes with conscious beings inside them. And if we can do that, then other civilizations might have already done it. They might have done it billions of years ago. The simulation hypothesis becomes less like science fiction and more like an inevitability. It becomes a question about our own future as much as our present. Consider this historical parallel. In 1905, Albert Einstein published his theory of special relativity. It fundamentally changed how we understood space and time. But here's what's interesting. For decades, most physicists rejected it. It seemed too bizarre. It violated intuitions that had been accepted for centuries. But Einstein had the mathematics. He had the logic. They realized that intuition isn't always a reliable guide to reality. Reality is stranger than we thought. The simulation hypothesis might be going through a similar transition right now. We're in the phase where it seems too bizarre, but we have the mathematical arguments. We have the physics that makes it plausible. And slowly, that's changing how serious thinkers approach the question. Let me give you another concrete historical example. In the 1920s, the idea that the universe was expanding was considered outrageous. Most astronomers believed the universe was static and eternal. But Edwin Hubble's observations in 1929 showed that galaxies were moving away from us. The universe was expanding. This seemed impossible. It violated everything astronomers thought they knew. But the evidence was clear. And within a generation, the expanding universe became accepted fact. Now we use it as the foundation for understanding the Big Bang and the origin of the cosmos. The simulation hypothesis might follow a similar arc. Right now, it seems impossible. But as evidence accumulates and as our technology advances, it might become increasingly difficult to dismiss.
This also has profound implications for how we approach technology and ethics. If consciousness can exist in digital form, if beings can be simulated, then we have moral responsibilities we haven't fully grappled with yet. Creating a conscious simulation would be creating life. It would be creating minds capable of suffering and joy. That's not something to take lightly. It forces us to think about the ethics of creation itself. In 2023, ethicists at Oxford University published a paper arguing that if we ever do create conscious simulations, we might have an obligation to ensure they have good lives. We might be morally responsible for their well-being. That's a completely new category of ethics, and it's not speculative anymore. It's becoming a real consideration as our technology advances. Here's why this matters today. We're already creating artificial intelligences. We're already training neural networks to think and learn. We're already building systems that can generate text, images, and ideas that rival human creativity. If we continue on this path, we might eventually create an AI that's genuinely conscious. We might create a mind, and if we do, we'll have to ask ourselves, what do we owe that mind? What are its rights? Can we delete it? Can we modify it? Can we copy it? These aren't abstract philosophical questions anymore. They're practical questions we might have to answer in the next 10 to 20 years. The simulation hypothesis forces us to think about these problems now, before we're forced to confront them in practice. It also changes how we think about meaning. If we're in a simulation, our purpose might be different from what we've always assumed. We might be part of an experiment. We might be entertainment. We might be something the creators haven't even considered. But here's the liberating part. That don't change what we should do. We should still pursue knowledge. We should still seek connection. We should still try to reduce suffering and increase flourishing. These values don't depend on whether reality is fundamental or simulated. They depend on the fact that consciousness exists, that experience matters, that we have the capacity to affect the world around us. The simulation hypothesis actually makes the case for these values stronger. Because if our reality is constructed, if it's intentional, then that construction has meaning, and we're part of that meaning. We're not just passive observers, we're active participants in the universe's self-exploration. We're consciousness examining consciousness. We're the universe becoming aware of itself, and that's the most profound thing we could possibly be. Whether we're in a simulation or not, that truth remains. We're here, we're conscious, we're capable of understanding, and that's enough. That's everything. The simulation hypothesis isn't about dismissing reality or retreating into nihilism. It's about expanding our sense of what's possible. It's about recognizing that reality might be far stranger and more wonderful than we ever imagined. It's about taking seriously the possibility that we're part of something larger, something intentional, something that deserves our wonder and our respect. So the question isn't really whether we're in a simulation. The question is, does it matter? And the answer is yes and no. Yes, because understanding the nature of reality is fundamental to understanding ourselves. No, because the way we should live, with curiosity, compassion, and courage, doesn't change either way. We're still here. We're still capable of creating meaning, and that's what matters most. The simulation hypothesis challenges everything we think we know about existence. It forces us to ask deeper questions about consciousness, about reality, about what it means to be alive. And the more we explore these ideas, the more we realize that the universe is far stranger and more wonderful than we ever imagined. The question of whether we're living in a simulation might never be definitively answered. But the journey of exploring it, that changes us. It expands our thinking. It opens us to new possibilities. It makes us more curious about the world around us and our place in it. If this kind of thinking resonates with you, if you love exploring the big questions about the future, about consciousness, about the nature of existence itself, then subscribe to Future Frontiers.
We dive into these ideas every week, pushing the boundaries of what we think we know and exploring the possibilities that lie ahead. The future is full of wonder.